Welcome to this instructional video on the BondMaster 600 bond tester. This video illustrates how to use the BondMaster 600 tester in mechanical impedance analysis or MIA test mode to detect smaller disc bonds in honeycomb composite. For typical inspection procedures, such as inspecting an aircraft component, turn on the instrument and connect the MIA probe. When prompted, press Continue, then Accept to load the default settings. Set the frequency to the value recommended by the inspection procedure. For this video, we will use the default value of 10 kHz. Set any other parameters as needed if required by the procedure. Ensure that the probe tip is covered with Teflon tape or an equivalent protection film. Never inspect with damaged tape, as this will scratch the surface and damage the probe. You may use backing foam to achieve better results. Place the probe on an area free of defects and press the null key. It's important to know where the simulated defects are located to avoid mistakes during calibration. Maintain a constant pressure on the probe tip. One easy way to keep the pressure constant is to use the weight of your forearm to press the probe against the surface. This helps ensure constant pressure and minimal effort. Slowly scan over the simulated disc bond while maintaining constant pressure. When done, press the freeze key. Press the gain key and adjust the sensitivity to have the disc bond at 70 to 90% of the full screen height. If needed, adjust the angle of the signal. The basic calibration is now complete. Press freeze again to restart acquisition and scan the entire standard. In this example, the small disc bond goes upward on the screen while a repaired area goes down, enabling indications to be easily identified. Now we'll discuss how to define working parameters for inspecting honeycomb composite with the MIA mode. This section is targeted at users who write procedures or develop bond testing applications. The most critical parameter is the test frequency. Assuming you have a working MIA configuration, press and hold the null cal key to enter the frequency calibration mode. Maintain the probe on the disc bonded area while keeping a constant pressure. Hold the probe as straight as possible and aim for the center of the disc bond defect. While you hold the probe, the instrument will self-adjust its sensitivity. Once you feel the instrument has stabilized, press the bad part key. Move the probe onto a defect-free area, hold it there, and press the good part key. Your result should resemble the following screen. Watch for the spectrum peaks. If you mostly obtain a single negative peak, this is a sign that the calibration went very well. In that case, press Done. However, if you obtain several peaks, this may be a sign of problems or a failed calibration. If you have a problem, first try pressing back and redoing the entire frequency calibration process. This often solves the problem when it's caused by incorrect probe positioning or uneven pressure. In rare cases, the composite application is just very difficult to solve, and you will always obtain several peaks during the frequency calibration. When that happens, we recommend using the first strong negative peak for frequency selection. Press Done to exit the calibration menu. The next critical parameter to set is the gain and/or probe drive. Since the MIA probe exhibits a strong difference in sensitivity along its frequency range, it is critical to ensure that the combination of gain and probe drive does not cause signal saturation. Be aware that gains over 55 dB may be needed at frequencies below 10 kHz, but gains as low as 25 dB may be required at frequencies around 15 kHz. In summary, if you observe or suspect saturation, remember to check the gain and possibly lower the probe drive as needed. We hope you enjoyed this video on detecting smaller disc bonds in honeycomb composite using the mechanical impedance analysis method. For more information about Olympus bond testing solutions, contact your local representative or visit www.olympus-ims.com.